When dealing with knob and tube wiring, several assessment methods can be employed to evaluate its condition and safety. Firstly, a megger test, also known as an insulation resistance test, can be used. This test measures the electrical resistance between conductors and ground. A low reading suggests potential insulation breakdown, which can lead to electrical hazards. Secondly, thermal imaging can be utilized. A thermal imaging camera can detect areas where heat is being generated in the wiring. This heat generation could be due to loose connections or overloaded circuits. In addition to thermal imaging, an infrared scan can be performed to identify heat buildup in electrical components and wiring. The third method is voltage drop testing, which measures the voltage drop between the electrical panel and various points in the wiring system. An excessive voltage drop can indicate overloaded circuits or poor connections. Fourth, arc fault circuit interrupters, or AFCIs, can be installed. AFCIs are devices that can detect electrical arcs, which are a common cause of electrical fires. Installing AFCIs in the electrical panel can provide additional protection. It is important to consider several factors when assessing knob and tube wiring. Limited access can pose a challenge, as visual examination and load testing may not be possible in all areas of the wiring system, particularly in concealed areas. The age and condition of the wiring are also critical factors. Knob and tube wiring is typically old and may have degraded over time. Therefore, the condition of the wiring, including its insulation and connections, must be carefully evaluated. Safety is paramount when performing any electrical testing. Appropriate precautions must be taken to avoid electrical shocks or fires. Only qualified electricians should conduct such tests. Given these considerations, it is generally not recommended to simply sign off on knob and tube wiring without conducting a thorough assessment using multiple methods. If the assessment reveals significant issues with the wiring, it is generally advisable to either run new wiring or consider a complete rewiring of the home. In some cases, a conditional endorsement may be possible if the assessment shows minimal issues and the homeowner agrees to implement recommended repairs or upgrades. It is highly recommended to consult with a qualified electrician who has experience with knob and tube wiring for a proper assessment and guidance on the best course of action. This is due to the limited access, age and condition of the wiring, which requires a trained electrician to assess the risk accurately. Megger testing applies a high voltage DC current to the wiring and measures the resistance to ground. The higher the resistance, the better the insulation. A typical passing value is 1 megohms or greater. However, this value can vary depending on the age and condition of the wiring. Low megger readings indicate that the insulation is failing, which increases the risk of electrical shock and fire. Thermal imaging and infrared scans are both non-destructive methods that can detect hot spots in the wiring. These hot spots are often caused by loose connections, overloaded circuits, or damaged insulation. By identifying these hot spots, electricians can pinpoint areas that need repair or replacement. These should not be the only test that is conducted. It is a general idea of where the problems lie. Voltage drop testing measures the amount of voltage lost between the electrical panel and the end of a circuit. Excessive voltage drop can cause appliances to malfunction, lights to dim, and can even damage electrical equipment. A voltage drop of more than 3% is generally considered unacceptable. AFCIs are designed to protect against arc faults, which are a common cause of electrical fires. Arc faults occur when electricity jumps between two conductors, creating a spark. AFCIs can detect these sparks and quickly shut off the power to the circuit, preventing a fire. When assessing knob and tube wiring, electricians should also look for signs of physical damage, such as cracked or frayed insulation, loose connections, and corroded wires. These types of damage can increase the risk of electrical shock and fire. In addition to these assessment methods, electricians should also review the home's electrical load to ensure that the wiring is adequate for the current electrical demands. Knob and tube wiring was typically installed in homes with much lower electrical demands than today's homes. Overloading knob and tube wiring can cause it to overheat and fail. If an electrician finds significant issues with knob and tube wiring, they will typically recommend rewiring the home. Rewiring involves replacing the old knob and tube wiring with modern, grounded wiring. This is the safest and most reliable way to ensure that the home's electrical system is up to code and can handle the current electrical demands. Rewiring a home can be expensive, but it is a worthwhile investment in the safety of the home and its occupants. In some cases, homeowners may be able to obtain financial assistance from their local utility company or government agencies to help cover the cost of rewiring. While complete rewiring is often the best solution, there may be situations where a partial rewiring or other repairs can be made. However, these types of repairs should only be done by a qualified electrician and should be carefully considered to ensure that they do not compromise the safety of the electrical system. Ultimately, the decision of whether to rewire a home with knob and tube wiring is a complex one that should be made in consultation with a qualified electrician. The electrician can assess the condition of the wiring, evaluate the home's electrical needs, and provide recommendations on the best course of action. The electrician will look for signs of damage or deterioration, such as cracks, fraying, or brittleness in the insulation. They will also check for loose connections, corroded wires, and evidence of past electrical problems. The electrician will use specialized testing equipment to measure the resistance of the insulation and the voltage drop in the circuits. These tests can help identify hidden problems that are not visible to the naked eye. The electrician will ask the homeowner about their electrical usage habits and plans for the future. This information will help the electrician determine whether the existing wiring is adequate for the home's current and future electrical needs. Based on their assessment, the electrician will provide the homeowner with a detailed report outlining the condition of the knob and tube wiring and recommendations for repairs or upgrades. If the electrician recommends rewiring the home, they will provide a detailed estimate of the cost and timeline for the project. The estimate should include the cost of materials, labor, and any necessary permits. The homeowner should carefully review the electrician's report and estimate before making a decision about how to proceed. They should also get multiple estimates from different electricians to ensure that they are getting a fair price. Rewiring a home with knob and tube wiring is a significant undertaking, but it is an important investment in the safety and value of the home. By working with a qualified electrician, homeowners can ensure that their electrical system is safe, reliable, and up to code. When it comes to assessing knob and tube wiring, here is a more detailed breakdown of each assessment method. Firstly, megger testing. A megger meter, often referred to as a megger, is a specialized instrument designed to measure high insulation resistance values. In the context of knob and tube wiring, a megger applies a direct current voltage, typically ranging from 500 volts to 1000 volts, between a conductor and ground or between two conductors. The instrument then measures the amount of current that leaks through the insulation. A high resistance reading indicates good insulation, while a low reading suggests insulation degradation. The specific threshold for an acceptable reading varies depending on factors such as the age and condition of the wiring, but generally, a reading of several megohms or higher is desirable. Megger testing helps identify hidden insulation weaknesses that could lead to electrical faults. Secondly, thermal imaging. Thermal imaging cameras, also known as infrared cameras, detect and visualize heat patterns. When applied to knob and tube wiring, these cameras can reveal areas where the wiring is overheating. Overheating can be caused by several factors including loose connections, overloaded circuits, or insulation breakdown. Loose connections increase resistance, leading to heat generation. Overloaded circuits cause excessive current flow, which also generates heat. Degraded insulation allows current leakage, resulting in localized heating. The thermal images produced by the camera display temperature variations as color gradients, with hotter areas appearing brighter. By identifying these hot spots, electricians can pinpoint specific areas of concern that require further investigation and potential repair. Thirdly, infrared scanning. Infrared scanning is similar to thermal imaging, but it often involves a more systematic and comprehensive assessment of the entire wiring system. An electrician uses an infrared scanner to scan all accessible knob and tube wiring, looking for temperature anomalies. The scanner captures thermal images, which are then analyzed to identify potential problems. The analysis may involve comparing temperature readings to establish benchmarks or looking for significant temperature differences between adjacent wires or components. Infrared scanning can help detect subtle problems that might be missed by visual inspection alone. Fourth is voltage drop testing. Voltage drop testing assesses the integrity of the wiring by measuring the voltage at various points along a circuit. The test involves applying a known load to the circuit and then measuring the voltage at the beginning and end of the circuit, as well as at intermediate points. The voltage drop is the difference between the source voltage and the voltage at the load. Excessive voltage drop indicates that the wiring is not able to efficiently deliver power to the load. This can be caused by undersized wires, loose connections, or corrosion. A voltage drop of more than 5% is generally considered unacceptable and may require further investigation and repair. Fifth, arc fault circuit interrupters AFCIs. AFCIs are advanced circuit breakers that are designed to detect arc faults, which are dangerous electrical conditions that can lead to fires. Arc faults occur when electricity jumps between two conductors, creating a spark. This can happen due to damaged insulation, loose connections, or other wiring problems. AFCIs use sophisticated electronics to distinguish between normal arcing, such as that which occurs when a switch is turned on, and dangerous arc faults. When an arc fault is detected, the AFCI quickly trips, cutting off the power to the circuit and preventing a fire. Installing AFCIs on circuits with knob and tube wiring can provide an extra layer of protection against electrical fires. Limited access is a significant challenge when assessing knob and tube wiring. Much of the wiring is concealed behind walls and ceilings, making it difficult to visually inspect or test. The electricians may need to use specialized tools such as periscopes or snake cameras to access these hidden areas. Even with these tools, it may not be possible to fully inspect all of the wiring. This limitation means that any assessment of knob and tube wiring is likely to be incomplete. Age and condition are also critical factors. Knob and tube wiring is typically very old, often dating back to the early 20th century. Over time, the insulation on the wires can become brittle, cracked, or damaged. This degradation increases the risk of electrical shock and fire. The connections between wires can also loosen or corrode, leading to increased resistance and heat generation. A thorough assessment must take into account the age and condition of the wiring, as well as any signs of past repairs or modifications. Safety concerns are paramount when working with knob and tube wiring. The wiring may be in poor condition, and there is a risk of electrical shock or fire. Electricians must take appropriate precautions to protect themselves, such as wearing insulated gloves and using insulated tools. It is also important to energize the wiring before performing any testing or repairs. Only qualified electricians with experience working with knob and tube wiring should attempt to assess or repair it. Considering these factors, it is generally not advisable to simply sign off on knob and tube wiring without conducting a thorough assessment using multiple methods. A cursory inspection may not reveal hidden problems, and it could give a false sense of security. A comprehensive assessment should include megger testing, thermal imaging, voltage drop testing, and a visual inspection of all accessible wiring. If the assessment reveals significant issues with the knob and tube wiring, the best course of action is typically to rewire the home. Rewiring involves replacing the old knob and tube wiring with modern, grounded wiring. This is the safest and most reliable way to ensure that the electrical system is up to code and can handle the electrical demands of modern appliances. However, rewiring can be expensive and disruptive. In some cases, partial rewiring may be an option. This involves replacing only the most problematic sections of the wiring while leaving the rest in place. However, a partial rewiring is not always a good solution, as it can create a mix of old and new wiring that is difficult to maintain. Another option is to install arc fault circuit interrupters AFCIs on the circuits with knob and tube wiring. As mentioned earlier, AFCIs can provide an extra layer of protection against electrical fires. However, AFCIs do not address the underlying problems with the wiring, such as degraded insulation or loose connections. In some cases, a conditional endorsement may be possible. This involves acknowledging the presence of knob and tube wiring but requiring the homeowner to take certain steps to mitigate the risks. These steps might include installing AFCIs, having the wiring inspected regularly, or limiting the use of certain appliances. A conditional endorsement should only be considered if the assessment shows minimal issues with the wiring and the homeowner is willing to take the necessary steps to ensure safety. Ultimately, the decision of how to deal with knob and tube wiring should be made in consultation with a qualified electrician. The electrician can assess the condition of the wiring, evaluate the risks, and provide recommendations on the best course of action. The homeowner should carefully consider the electrician's recommendations and make an informed decision that is in the best interest of their safety and the safety of their home. Electrical safety is paramount when dealing with old wiring. Always disconnect power before inspecting or working on any electrical components. Use insulated tools and wear appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, it is best to call a qualified electrician. When inspecting knob and tube wiring, look for signs of damage or deterioration, such as cracks, fraying, or brittleness in the insulation. Also check for loose connections, corroded wires, and evidence of past electrical problems. Pay close attention to areas where the wiring passes through walls or ceilings, as these are common areas for damage to occur. If you find any problems with the wiring, do not attempt to repair it yourself unless you are a qualified electrician. Improper repairs can create a fire hazard or an electrical shock hazard. It is always best to call a qualified electrician to assess the situation and make the necessary repairs. Knob and tube wiring is an outdated and potentially dangerous type of electrical wiring. If you have knob and tube wiring in your home, it is important to have it inspected by a qualified electrician. The electrician can assess the condition of the wiring and recommend the best course of action to ensure your safety. Several factors that can affect the condition of knob and tube wiring over time, including temperature fluctuation. Extreme temperature changes can cause the insulation to expand and contract, leading to cracks and brittleness. Humidity can also affect the insulation, causing it to degrade more quickly. Rodents and insects can damage the wiring by chewing on the insulation or building nests in the wiring. Overloading the wiring can cause it to overheat, which can damage the insulation and increase the risk of fire. There are some common misconceptions about knob and tube wiring. One misconception is that it is always dangerous and must be replaced immediately. While knob and tube wiring can be dangerous, it is not always necessary to replace it. If the wiring is in good condition and is not overloaded, it may be safe to leave it in place. However, it is important to have it inspected regularly by a qualified electrician to ensure that it remains safe. Another misconception is that it is easy to repair knob and tube wiring. In fact, repairing knob and tube wiring can be quite challenging as it requires specialized knowledge and skills. It is always best to call a qualified electrician to repair knob and tube wiring. When assessing knob and tube wiring, there are several specific things that electricians look for. They look for the type of insulation used on the wires. Original knob and tube wiring typically used rubber insulation, which is prone to cracking and deterioration over time. Modern knob and tube wiring may use plastic insulation, which is more durable. They also look for the size of the wires. Knob and tube wiring typically use smaller gauge wires than modern wiring. This means that it is not capable of handling as much current, and they look for the presence of any modifications to the wiring. Modifications can compromise the safety of the wiring. In addition to these specific things, electricians also look for any other signs of damage or deterioration, such as loose connections, corroded wires, and evidence of past electrical problems. They also use specialized testing equipment to measure the resistance of the insulation and the voltage drop in the circuits. Based on their assessment, the electrician will provide the homeowner with a detailed report outlining the condition of the knob and tube wiring and recommendations for repairs or upgrades. The homeowner should carefully review the electrician's report and estimate before making a decision about how to proceed. They should also get multiple estimates from different electricians to ensure that they are getting a fair price. Dealing with insurance companies in relation to knob and tube wiring can be challenging. Some insurance companies refuse to insure homes with knob and tube wiring, while others require a thorough inspection and potential upgrades before providing coverage. It is important to check with your insurance company to determine their specific requirements. If your insurance company requires an inspection of your knob and tube wiring, be sure to hire a qualified electrician with experience working with this type of wiring. The electrician can provide a detailed report outlining the condition of the wiring and recommendations for repairs or upgrades. You can then submit this report to your insurance company to demonstrate that the wiring is safe or that you are taking steps to make it safe. Remember that the ultimate goal is to ensure the safety of your home and family. By taking the necessary steps to assess and address any issues with your knob and tube wiring, you can help protect your home from electrical fires and other hazards. Consulting with an expert electrician will give the best course of action.